Alright, hello everybody, and welcome to another live training with Unity. My name is Mike Geig. Thank you all for being patient. Somehow, someway, the channel opened up like 10 minutes early, so a lot of you were sitting here looking at a blank screen, and I just happened to be sitting at my desk and glanced up and noticed and freaked out a little bit. So, hello, I hope everyone is doing alright. Let me know if we are having any audio issues. I haven't done a live training in quite some time, so I hope my software is working correctly. I tested it a little bit earlier, and hopefully this goes off without a hitch. But if there's some setting or something that I forgot to do, please let me know. As always, feel free to use the chat to ask questions. I'm going to attempt to read the chat while I'm talking. I know it's been a while, so I'm just kind of going over the rules again. And hopefully we don't have any issues and we can talk about plugins and all that stuff. So while we're talking about plugins, I figure we might as well plug Twitter. So if you have any questions, comments, concerns, feel free to follow us on Twitter at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at The Ant Ranch. So cool. So a lot of you, even so far, have been asking just a ton of questions in chat about what are plugins and are assets from the asset store plugins and this and that and the next. And the answer is maybe assets from the asset store plugins, but a plugin in Unity is a very specific thing. And generally, it's much easier to think of plugins in the terms of, say, compiled code, libraries, DLL files, if you're familiar with those. So today we're going to talk about those, and for those of you who have been asking, we're going to be using C# to make managed plugins. We're going to be using C++ to make native plugins on a bunch of different platforms, and there's going to be a little bit of C only by virtue of us using C++, but actually using C. So we're not actually going to be creating like full C++ classes or anything like that. It's really actually C, but we call it C++, whatever. We're not going to be doing Java. Some people asked about that. We're not going to be doing Lua or anything like that. So anyway, and then if anyone's having video problems or if people are posting in chat about video or audio problems, please have them refresh the window, which will make all that stuff come back, and it'll be fixed. Okay, so let's talk about plugins. What are plugins? All right. Plugins are essentially bits of modular code, okay? They're code that exists outside of Unity. So Unity is an engine, and game engines encapsulate all of the common functionality amongst many, many games, like particles and rendering and physics and stuff like that. Plugins allow us to extend Unity to do some specific stuff, right? And there's basically two types of plugins. There's managed and there's unmanaged. Now, I do want to point out that pretty much everything that I'm talking about is sort of one of those things where you could say, well, not technically, or well, you could, right? So I'm talking about this in a very broad sense because we're talking about this kind of for beginners. So a lot of the things that I'll say, you could actually put in a lot of work and kind of do the opposite and stuff like that. So I'm just going to try to lay out kind of a baseline for all of you. And if you want to on YouTube later, you can go in the comment section and be like, well, you're wrong because I can do this with fine, whatever. That's fine. I'm going to try to make this simple. Okay. All right. So plugins are bits of modular code. They're generally compiled, right? So in Windows, we'd create like a DLL, right? C# would create a DLL. We would create a .bundle file in Mac, specifically OS X, right? And you know what? I can't think of, is it .libs for Linux? I don't ever use Linux, so I can't remember off the top of my head. But the managed plugins, the ones that are made in C#, will work on pretty much anything, right? And the unmanaged or the native stuff, you kind of have to build for the specific platform you're targeting. You could make it for a different platform, or make one work for the other, but it takes a lot of work. So I'm just going to blanket statement that you probably should rebuild for whichever platform you're targeting. And I'll show you exactly what I'm talking about. And a plugin, like I said, it allows us to extend the editor and gives us functionality that we don't normally have. It's great for doing things like, hey, I wrote a combat system with players and enemies and all this robust code, and it's in C# and I've compiled it into a DLL. I don't really want to rewrite all that stuff in Unity. Well, cool. You can just turn that DLL into a plugin, bring the code in, whatever. Or you might be like, hey, I bought this really neat RFID reader, right? The piece of hardware. and they gave me some DLLs for me to call specific functions. Cool, you know, you don't turn that into a plugin. That DLL is a plugin. Just bring it into Unity, call the functions, right? I have an Oculus Rift. I have a specialized trackpad. I have cameras. I have GPSs. I have this weird or unique hardware or whatever, or code that I want to reuse, or I bought this piece of software. And basically, if you get a code library, right, like a DLL file or a .bundle file, right, cool, you've got a plugin, right, and you can use that plugin. Now, like I said before, I'm going to say it again. Pro allows you to do managed and unmanaged, so native and managed code, and free allows you to only do managed. I only have Pro. I thought about removing the license that I have and downgrading to free just to test this out, to figure out what free and pro, where the barrier is, but I ran out of time, and I just didn't want to. So basically, it's kind of a gray line where one functionality stops and then one picks up. So follow along. If you're in free, feel free to post in chat or mention in comments or whatever exactly what you can and can't do with free. I'd be curious to know as well. It's been a long time since I looked at this stuff with free, and as I always say, I really wish Unity had like a button for developers where you can be like, now I'm in free and now I'm in pro, and there might be one, but I don't really know what it is. Let's see here. A lot of people are talking about Russian, so sorry, I don't speak Russian, and some people are talking about low audio. I hope the audio is alright. I do project a little lower, just so I don't pick up a lot of background noise and stuff, so if your audio is low, maybe put on headphones or turn it up or watch it again later with headphones or whatever. Okay, so plugins are basically going to enable us to extend the editor in some way, and the first thing we're going to do is we're going to talk about managed managed plugins. Okay, and these are really easy, and these are things that free users can do. These are things we don't need any special software. We can do completely with Unity and MonoDevelop. Right, MonoDevelop has the capabilities to build this stuff. So let's build for ourselves first a managed plugin. All right, and again, and real quick, we're going to be doing really, really simple examples, and so you kind of have to use your imagination to how we could extend this to do much more complex stuff. I'm doing simple stuff so that we get through it all, because there's a bit to talk about, because there's quite a bit of stuff I want to show you. All right, so I have basically just an empty Unity project with that's called plugin test. It's got nothing in it, and I have MonoDevelop here open. And I didn't open MonoDevelop by double-clicking on a script in Unity or whatever. I just opened the software MonoDevelop. I wonder if any of you knew you could actually do that. So I opened MonoDevelop, and what I'm going to do is I'm going to build a managed C# library here. Now, I could use Visual Studio. I could use Xcode, targeting the Mono platform, whatever. But I'm going to use MonoDevelop. So I'm going to hit New under Solutions, and I'm going to go to C# and I'm going to grab a library, because that's what I'm making. I'm making a DLL, a dynamically linked library, okay, and that is going to be the basis of my managed plugin, okay, and so now basically you just got to give this guy a name, and let's go ahead and call this random number. Basically, we're going to create a plugin that's going to generate a random number, right? And that, like I said, that's not, I mean, I'm not going to blow anyone's minds here, but it's the actual interoperability between DLL's compiled code and Unity that I want to illustrate, not these sweet, awesome code libraries. So we're just basically going to be generating a random number. Let's pretend some mad scientist gave us some amazing code that generates perfectly random numbers based on, I don't know, dark particles or something like that. Who cares? Whatever. So we have a library named random number. I'm just going to, I don't really want to put it in my documents, but let's drop it on the desktop. Desktop it is. All right, so it'll be on the desktop there. And we'll go ahead and hit OK. And we're just basically going to get this default myclass.cs. And we have basically a namespace, random number. The class is by default myclass with a constructor. I don't care about a constructor, so I'm just going to say goodbye, constructor. And I'm simply going to create a public function, which is going to be public int get random. Let me zoom in here too. I bet my code is a little small. There we go. All right. See if I can't make a bunch of strange noises while I'm at it. And so here we go. We have basically just some class, my class, with a public method returns an int called get random, and inside there we're just going to say random rand equals new random, and I'm not going to bother seeding a random number or anything like that, and I'm just going to return rand.next, which is going to give me an integer, and that's my whole plugin, right? Basically, yeah, that's kind of it. Someone asked in chat what's the difference between a DLL and an API. So APIs are basically interfaces that allow us to plug our code into some other code. All right, so let's say if I wanted to write some software that communicated with like Dropbox, you know, the file sharing cloud storage Dropbox, I would need to utilize the Dropbox API to connect to it and find all this stuff. So DLLs are basically compiled code that you actually physically have access to, either through a network share or something like that, as where APIs are basically just, well, I'm being general, right? They're basically just ways of talking to other pieces of running software. And there are other ways we could describe that, and there's other things we can do with it. But in a nutshell, DLLs libraries are just going to be compiled code that we're going to have access to, and APIs are interfaces that we do function calls with and stuff like that. All right, so something like that. So yeah, so basically, you know, this code is pretty simple. This is commented up here. I don't really care about that. Someone asked what the namespace is. The namespace just defines a scope for this class, so it's going to be a random number. We'll see how we use that later. The class name is my class, but function get random. So, all right, I'm just going to go ahead and save this, and then I'm going to build it. Build all, and it should say successful, and it does say successful. So cool. I am done with my managed plugin. That's it, right? It is built. So now let's look at how we integrate that with Unity, right? And remember, this is managed. So these are the things that free users can do. And I could create a whole collection of classes. I could basically do all sorts of stuff. But do know that this is a library. This does not know anything about Unity, right? I can't use any Unity specific stuff. No mono behavior, no starts and awakes, and no physics.raycast. None of that stuff is in here, right? This is pure C++, and this is pure C++ based on the mono libraries. Okay, so just keep that in mind. So, so this code is completely separate. So that's been built. I'm actually just going to leave MonoDevelop. Goodbye, MonoDevelop. And here I am looking at Unity. Okay, and you could see it's empty. There's nothing in it. So what I'm going to do first is I'm going to locate my random number project, which you remember I saved to the desktop, random number. And this is what MonoDevelop created for us. And I'm going to open up the bin file, debug, and I see the DLL. So this is compiled code. This is the code I just wrote. It's stored inside this file. Real quick, I'm going to read through chat. DLL, library of classes, API, library of public methods. Yeah, that sounds pretty good. Hotnick87 said that, so that's a pretty good way to sum it up. Let's see. Let's see here. Can I write C++ games in Unity, not C#? Not really. You could write all of your code in C++ and as a native plugin, but it would be a really bad idea. Let's see here. Okay, a lot of stuff. How's the performance of managed plugins compared to the normal C# scripts in Unity? Is there a benefit, penalty for compiling to DLL? That's a good question, Pixel Stealth. Pixel Stealth asks if there is a performance benefit to compiling our code to a DLL and then using it in Unity. I believe no. I believe it would be better to have our code in in Unity without being in a managed plugin. I think the call to the managed plugin has a lot of overhead. But that is completely unsubstantiated. I've not tried it. Basically, we use managed plugins if we have a whole lot of code we want to reuse, or we're trying to access some hardware or something like that. Let's see here. Someone said, why am I using C# extension for C++ code? Because this is C# code. This is a managed plugin. All right. Okay, so we're all on track. I'm not using Ion. Anyway, I mean, you guys can explore how to write your own C# managed code. That's really irrelevant right now. Mostly I'm interested in getting Unity to talk to this plugin. So what I'm going to do is I'm going to basically click and drag this file into the project view, and there it is. And that basically imports the plugin. Now, Unity doesn't know that this is a plugin, and Unity doesn't really know how to work with this. So what I need to do is I need to create a special folder. And the folder's name is plugins. and all my plugins go in this plugins folder. This plugins folder can be wherever we want, as long as its name is plugins. All right, and then I'm going to click and drag that in there, and so now I have a plugins folder with my randomnumber.dll inside. So this is my managed plugin. Okay, so let's write some code that's going to allow us to interface with this plugin that we basically just made. So I'm going to create a new script. So I'm going to go to create C#, and let's just call this something along the lines of test managed. So this mono behavior is going to test my managed plugin. All right, and I'm just going to click and drag that onto the main camera. This is a script I created in Unity, thus it's a mono behavior, thus it's all that good stuff. And let's see here, let's go ahead and run this. Someone said in chat that there's no performance difference between managed libraries because they're all turned into a managed library when deploying. So there you go. Let's see here. If I create a class library in Visual Studio, do I need to target a specific .NET framework for it to be usable in Unity? So that question is by Shadad Jr. Shadad Jr. Basically, what you want to do is you want to target the same type of Unity project you're making. So if you're using Unity 32, you're going to want to make a library that's 32-bit, 64 for 64. If you want your managed library to be usable in more than just Microsoft platforms, you should target .NET 2.0, right? Because Unity is currently based on Mono, I think 2.2, which is very similar to .NET 2.0. If left alone and you build a large library with like .NET 4, you're going to have some issues. So we don't have to worry about targeting that with that stuff because we built this with Mono Develop. If we had built it with Visual Studio, chances are we still wouldn't need to worry about it because we're not using any of that functionality. But if we attempted to use functionality that exists in like .NET 4 and try to use it inside Unity, it's going to have problems. All right. Let's see here. Just trying to read through some of these. Okay. Yeah, there's a lot of questions. I'm just trying to move along here. A lot of questions that don't have anything to do with what we're talking about, and a lot of curiosity about basic language and syntax, which again, not super concerned with right now, because this is more about the plugins and not about syntax and how to program and things like that. All right, so we've created our test managed mono behavior here, and all I'm going to do is, since this is a managed plugin, it all kind of integrates rather nicely. I don't have to do a whole lot to make this whole thing work. So since it's managed and since it's in my plugins folder, all I'm really going to need to do is create an instance of it. So remember that namespace we created called random number? And someone asked me about what namespace is. The namespace we created was random number. So I'm going to do random number.myClass, which is the class we created, and then I'm going to create a variable of type myClass. I'm curious if it'll let me do this without the namespace. Equals new. No. So I need to have the namespace. Okay. I hadn't tried it without the namespace. I usually just have the namespace. So basically we're just creating a new instance of this class, which we're calling obj. And so that is effectively going to just have an object of this class. The class's type is myClass. And now all I'm going to do is I'm going to say print. And I'm going to say managed random number. We're going to be calling it managed so we know later when we get into native. And then we'll just do obj dot get random is the function we created. So there, that's, oh, and I'm missing a parentheses. So basically, that's all we need to do to use a managed plugin, right? The C#, and I suppose I can reopen that. Let's go file, open, desktop. You guys get to see all the fun stuff on my desktop. Where are you? This is the plugin code. We see I have a namespace, random number, public class, my class, public int, get random, and then it's just returning a random number. And here we can see we use the namespace, the class, we create a variable, call the constructor, and then we call the getRandom function and output it into print. All of this works. Unity automatically recognizes the namespace, recognizes the class name, all that stuff because there's a managed plugin, and so it's just going to work. If I come back into Unity now and I run this, it's not going to be anything spectacular, but we are going to see managed random number, and I get a random number. All right, so we have a managed plugin. Okay, now if I had taken this plugin, I could run this in iOS. I can run this on OS X, Mac operating system, right? I actually tested those, so I know for a fact this code, this project, without any changes, works cross-platform, at least PC, OS X, and iOS. My assumption is that it will also work in Linux. My assumption is that it will also work on Android, and so on, Windows Phone, and so on and so forth, right? So cool. Very basic managed plugin, all right? People in the chat who are asking about all these things that don't matter, like what I'm going to talk about next and stuff like that, just please stop, because the chat's actually moving really fast. I'm having a hard time reading all of it, and stuff like that. Someone posted in chat, you need to have using random number, and you don't, because it just knows about it, because it's managed plugins. We don't have to worry about it. Basically, yeah, the whole thing just is a wrapper around some random function. Okay, let's see here. So yeah, basically this all works, all platforms, whatever code I had in there. If someone had given me these libraries, if I needed to reuse code that I compiled from an old project into a new one, if I had some C# library that maybe interfaced with databases and stuff like that. Let's say I write some C# class library that does all this data handling and validation and backend sockets for servers and stuff like that. And is this throughput for all of this data. I don't really want to have to like import all the pieces of that code into Unity, right? So instead I just compile it into a DLL. It's a plugin, and I just call the plugin and send the plugin my data, and it does its thing, right? So, that's kind of what we do that for. So now let's talk about let's talk about native plugins now. So native plugins are things that are things that we're not going, or things that you're not going to be able to do with free, okay? So if you're using free, I apologize, you can watch, right? But you're not going to be able to follow along. So someone asked, is the plugins folder case sensitive? I don't know. So it worked with lowercase p. Let's make it capital P. Does it still work? Yeah, so apparently it is not case sensitive. So there you go. I hadn't really tested. Cool. All right. I think it's LPTT asked if there's a way for us to know what platform we're on. We'll talk about that. So everyone's jumping ahead with your questions. Just wait, we'll get there. All right, now let's talk about native plugins. So these managed plugins are going to work on a bunch of different platforms, but a lot of times we want to access specific hardware, right? It's really hard to write basically plugins that that will target low-level, like metal hardware, right? Like cameras and well, accelerometers are built in if you're using mobile devices, but like say Oculus Rift or special projectors that project in weird ways or have multiple screens or whatever. That's the sort of stuff we need plugins for, and we need to do native plugins for that. Now, native plugins, if written in a universal format, like say C++, or C for that matter, can be used across all of your devices. The difference is that you're going to have to recompile them for your target device. So you're going to see that I'm going to write some C++ code, and I'm going to build it for Windows, but I'm not going to be able to use that DLL I built for Windows on a Mac or on iOS, right? So I have to basically rebuild those on those platforms. And the nice thing is I don't have to change the code at all, right? I just have to import the code into that particular platform and build it. And we'll talk a little bit about that, all right? Now, so what I'm going to do is we're going to create a Windows DLL file. Like I said before, Macs use .bundles, and we could get DLLs to work on OS X, but they're kind of a pain, so it's just much easier just to rebuild. So I have Visual Studio here, just because I wanted to use Visual Studio. You do not have to use Visual Studio to do what I'm about to do. Basically anything that will build for you a C++ DLL file, right, you can use, right? I just happen to have Visual Studio, and so I'm going to use Visual Studio. And basically the steps are kind of all the same regardless of what you're using to build it, all right? But if you choose to follow along with Visual Studio, there's free versions out there, there's trial versions and stuff like that. You don't need 2013, you can use basically whatever version you want, just whatever you kind of want to do with that. All right, so what I'm going to do is I'm going to start a new project, and my new project is going to be a Visual C++ Win32 console application. All right, and this is going to be the basis of my Windows native plugin, and I am going to call this random number, just like the managed one, only this time I'm going to say random number DLL, so that I know that it is my native code. And then I'm going to hit OK. and I'm going to get this nifty window. It's going to ask me some stuff about my project, and I lied. So I chose console application, but I actually wanted just DLL. But I didn't see DLL listed in the menu, and there might have been one somewhere else, but this is how I know how to get to it. And I also want it to be empty. If I don't make it empty, it's going to give me all this other stuff, and I don't want any of that stuff. If you want that stuff, don't check this box, but I do not. It all depends on what you're trying to build. But basically, we're building a simple C++ plugin, all right? All right, so I have a DLL, empty project. Like I said, if you're using if you're using Xcode, maybe you're on OS X, right? You'd be building a Cocos bundle, and you would be adding your C++ classes there, right? And building that way, or whatever, right? The code is the same, and that's what's important. All right, and I'm just going to hit finish. So basically, however you would normally create a DLL, that's what you're going to do here, and whatever software you're going to use, whatever. So this is completely empty because I told it to be completely empty. So I'm just going to add a class to it, and this is gonna seem reasonable if you've ever done C++ programming. And if you haven't, you're gonna have no idea what I'm talking about. But that's fine because that's C++. No one knows what you're talking about anyway. So basically, I've just created my code file. This is basically the script that you get automatically when you make other stuff. And all I want to do is I want to encapsulate the functionality of my managed library, which is the generating random numbers, but I'm going to turn it into native C++. All right. And so what I'm going to do is I'm going to do #include IOStream, which is going to give me access to random numbers. Okay. And then so here's an important part. Now we're doing native code, right? And as such, we need to be very careful about this thing called name mangling. And I'm going to save you a lot of the details, and I'm just going to show you how to avoid it, because it's actually really simple, all right? But basically, since we're doing native code, and there's a possibility that there will be some misunderstanding about how things get compiled, names and stuff like that, we're just going to do something specific. We're going to say extern C, which is basically saying use the C-based naming conventions. This is going to avoid any of that mangling I talked about. It's not important to really know what that is. Just know that we're going to put our code inside here. Okay, so there we go. And no, I don't have Unity VS. So if anyone's wondering how Unity VS works, I've not used it, so I have no idea. So there you go. We have our extern C naming convention. So now basically we need to declare our function, and our function is just in this case going to be int get random, and we are going to basically inside say return. I promise I can code. Return rand. Oops. So that's going to give me some random number. Okay. This function, I'm going to call the function get random, is going to give me some random number. Now, there's one more step, all right? So even though this is in here, and I can build this, and this will turn this into a DLL, I need to specifically state that I want to export this function to be usable outside of the DLL. And I do that by saying underscore, DECL, so declare, spec, right? And then inside say DLL export. And this says, hey, I am sure this line of code here says, hey, I want to export this into the DLL. Now, if you're creating a whole bunch of functions, it can be kind of cumbersome to write this over and over and over again. So a very common thing that I like to do is to just define it. So I would say define like DLL exports, and I would define DLL export as this, like that. And then all I really need to do before each one is say DLL export, and I know, that means that I want to export it in my DLL file. All right, have I lost everybody? Great. So basically, this is just a macro. We're not really worried about that. This is what's important to come right before here. This is just a shorthand way in case I need to write it a whole bunch of times. So what this is going to do is this is going to build a native plugin that will allow me to call a function called getRandom, and it will return back to me a random number, right? And so let's go ahead and build this. So I'm just going to build solution. Assuming I didn't forget to do something fairly important, it should succeed, which in fact it does. You should be able to see that on the screen right down here. Build succeeded. All right. I'm sorry that everyone who is asking for Russian. Stop talking about Russian in chat. And I'm sorry that you decided to go play Call of Duty instead of watching. Sorry, whatever. Okay, so here we have our native plugin kind of done. All right, and again, that's it, right? Like I said, I'm talking simplistically about the syntax of the plugins themselves because it's the interaction between Unity and the plugins that I'm actually interested in. So let's pop back over to Unity and let's locate our new plugin. And so you'll see here we have on my desktop I created this random number DLL project, which is right here. I'm going to go into the debug folder for that, and here is my random number DLL, which is my plugin. And I'll just drop it right into my plugins folder, just like that. There we go. All right. So now we have that. We've got our native plugin available. So let's go ahead and write some code to interface with it. We can't interface with native plugins like we do with managed, right? So the managed plugin was easy. You know, I'll reopen this here so you can just kind of see. The managed plugin is basically just, hey, let me use this code that I know about, and we're going to use it, whatever, right? Now we need to do something a little bit more, I want to say dramatic. Okay, so what I'm going to do is I'm going to create a C# script, and this one is going to be test native. Test native is going to be the script that's going to allow me to test native plugins. Clicking back on my camera, I'm going to uncheck test managed because we don't care, we know that one works. And I'm going to drop test native on there, and let's go ahead and open it up. Now, this is a native plugin, and therefore I need to tell Unity to import it. Right? I need to tell Unity where the code is, what the code is, and I need to state it in a specific way so Unity knows about it, because it's not just going to automatically see it and know about it like it did with the managed one. All right. So basically, what I'm going to do is I need to use a special command called DLL import, which is going to tell it's going to tell Unity to import this DLL so that we have access to the stuff inside of it. All right. So now what I want to do is I'm going to say square bracket DLL import, and this isn't going to work just yet, and I know about that, so just one second here. So we're going to DLL import, and then we're going to specify the name of the file, right, that is in the plugins folder. In this case, it's going to be random number DLL. Now, I don't have to say random number DLL.dll. I don't specify the full name with the extension, just random number DLL without the extension. Okay, and so I'm going to do this, and it's going to say, hey, there's no such thing as DLL import. And they're correct. There's one more thing we need to do. I did it this way first so we could see it turn red, and then I can right-click it and go to Resolve, and this. What we need to do is we need to use this particular, or have this using statement at the top, using system.runtime.interop services. These interop services are how we import native DLLs. Okay, so this is my Windows DLL that I just created in Visual Studio. Now that I import the DLL, I need to specify what it is that I am importing, right? You should all know, or you should maybe know, or maybe you don't know, but the square brackets generally denote attributes. So this is just an attribute. It itself does not actually do anything. So we need the next line of code, which is going to say, hey, this is our DLL. What am I getting out of this DLL? All right. And so what I'm going to do is I'm going to specify a function to use. In this case, I'm going to call it private. I could make it public, but I'm just going to say private. It has to be static extern, right? It's an external function. So private static extern, those 3 words. Then I talk about the signature of my function. In this case, it is int get random. All right? This is the function we made in Visual Studio. All right? Int get random, right there. Okay, so that's what we're using. So here it is. This is me saying, hey, pull this function out of this DLL. If I had a bunch of functions, I would need to do both of these lines for each of the functions. So if I had 4 functions, I would have this line and then this line 4 times, 1 for each function. Okay, basically specifying what DLLs they're in. Now I have access to this function. Okay, so again, just like we saw with the managed code, now I can just use it. So this time though, I'm going to say native random number, just like this. And now I didn't instantiate an object. Instead, I just imported a function, get random. Okay, and so now that this line of code is done, I can pop back over into Unity and I can run this, and I should see native random number 41. Cool. All right. So our native plugin is in fact now working. Now, one of the things everyone's going to try to do right away is they're going to try to make C++ classes, right? And they're going to attempt to instantiate objects of those classes here inside Unity. And I'm going to say that it is possible, but you have to get into marshalling and you have to get into memory management and stuff like that. It's often better just to leave the C++ stuff on the C++ side of things and keep the C# stuff on the C# side of things without getting into tossing memory in between the two, marshalling these different resources, managing all this different memory. It's really a good idea to just have the C++ instantiate the objects of the classes and do whatever it needs to do and just expose functions, first of all, on the Unity side of things, right? So don't go around trying to instantiate objects of classes that are located inside DLLs because you're going to have some issues and it's going to take a bit of working through until you know what you're doing. If you're not sure or you don't believe me, just try once turning a C++ class with a string in it into a DLL and using it in C#. The problem is that strings are in fact not built in directly to C++, and so there's all these libraries you have to get involved in. It's a total pain, and that's just strings. That's not anything else, right? So it's really just a good idea to kind of keep stuff on the right side. So someone just asked, I'm confused, native plugins do work in Unity Free? No. Native plugins do not work in Unity Free. Managed ones do, native ones don't. Managed ones being the C# one we created first, the native one being the C++ one we just created now. Okay, so let's talk about this, right? So we have this DLL, and we have this code, and we have this project. Now, if I were to build this for Windows, it would run great. All right, let's pretend my random number is generated based on some hardware I have plugged into my computer, like a chaosolator, musical instrument, of me tapping on the surface, and that's going to generate some truly random number, whatever. So I have this, and this works fine. If I were to build this for OS X, it would not run, okay, because it won't be able to read this DLL. If I were to build this for iOS, again, it would not run. If I were to even open this project on OS X, again, it would not work. All right. So what we need to do is we need to kind of be smarter about how we're using DLLs, and this is a very common thing with native plugins, right? It's that we need to write code that's going to kind of encapsulate our DLL calls so that it will work on a native platform, right? Because right now, like I said, if I attempt to run this on something else, it's just not going to work. I'm going to get an exception, the thing's going to crash, it's no good. So what I want to do is I want to be intelligent. I want to basically write code that's going to say, hey, if this plugin for this platform works, right, then use it. And if it doesn't, all right, then we're going to do something else, okay? So, you know, we're going to kind of talk about that, right? One question here, did he put the DLL file from Visual Studio into Unity, or did he import it in the code? I physically moved the file. So picture me Roland. Here is the file. I moved it from Visual Studio and imported it directly into Unity. So Unity is going to use them here, right? And it's going to, the nice thing is when it builds this, it's going to provide the DLL with the final product. I don't need to worry about moving the DLLs and stuff like that. Unity is going to handle that for it. Or handle that for me, and it's not going to be a problem. So, something I've already done, kind of behind the scenes, is I've already recreated this native library on OS X and for iOS, right? The code is exactly the same, right? So, you see the code, and the code has not changed. All right, so what I have is I have this other plugins folder here. And so the first thing I'm going to pull in is this .bundle. All right, in Windows it looks like a folder, but I can see it's random number bundle. Oh, you can't see it at the bottom there because the screen is chopped off. But basically this here is a bundle, right? So the file name is actually random number bundle.bundle. Okay, if I was on an OS X machine, if I was on a Mac, this would look like a Lego block, right? But Windows has no idea what a .bundle is. It just thinks it's a folder, right? So if you're on a Mac and you see this, you're going to see a puzzle piece or like a Lego brick. And on Windows, you're going to see a folder. But basically, let me see. Can I get into like a list mode? There we go. Random number bundle.bundle. The .bundle is the Mac extension, and Windows has no idea what that is. So it just thinks that's the folder name, right? So just treat this as a single file. We can go into it, right? Because we're in Windows, and Windows thinks it's a folder, right? But this is a .bundle file. Think of it as a singular file. So don't put stuff inside of it. Don't move stuff inside of it, or else the OS X version won't work. So now to kind of just run through again what we have here. Here's the managed plugin we created earlier. Native C++, native C++ to Windows, the .dll file. Native C++ to OS X, which is a .bundle file. All right. Now let's talk about the iOS version. So iOS works kind of nice in Unity now. They've added a feature where if we put just the code files in a special folder, when we build this for iOS, they'll automatically be moved into Xcode and built for us into the library, which is really cool because that means we can just edit the code directly inside Unity folders, and then when we're ready to deploy it, right, it'll turn it into what we need. To do that, inside our plugins folder, we can create a new folder called iOS. And any iOS specific plugins go here. So you'll see here what I have is I have a .h file and a .m file, right, which were created basically as Objective-C files, but they only have C code in them. So basically the C++ we saw earlier, right? And so now I'm just going to click and drag, boop, and the code files can go directly in there. I didn't need to turn them into, I didn't need to compile them. These are not compiled. I can open these with Notepad. These are, can I? Let's see here. What happens if I just do open? Yeah, I'm just going to do that thing. But basically I can open these with like Notepad or WritePad or whatever. These are just text files, right? They're not compiled in any way, shape, or form. And when we build for iOS, Unity will automatically, like I said, import these into Xcode, build them, and turn them into my iOS plugin. All right. So now we basically have 3 plugins for 3 different platforms with the same code that does the same thing, right? And it seems like a lot of work, but this basically effectively gives me access to a bunch of different platforms, right? 4 plugins specifically. So now let's talk about how we can be smarter in Unity to determine exactly, which platform we're on and how exactly we can interface with this code. All right, because right now Unity is simply, if we look at MonoDevelop, it's going to import the Windows one, and it's going to fail if we're on iOS, if we're on Android, if we're on OS X for Mac, Linux, whatever. It's just going to fail, right? So we need to kind of be smarter about how we handle this bit, so that we can basically on the fly switch between platforms without having to change any of our code. All right. So let's go ahead and create a new class, which is basically going to wrap up all of this functionality for us. All right. Let me read through chat here real quick because I've kind of ignored it a little bit. Sorry about that. Let's see here. Sorry, I'm trying to scroll up because a lot of people are talking about something that happened earlier. Oh yeah, so if you're seeing an error, you're on free. Free won't allow you to do the native stuff. No native plugins in free. Let's see here. Yeah, basically everyone's just talking about native plugins. Unrelated. Can you tell the compiler to put the DLL in your Unity project folder instead of the project itself? Absolutely. That's just in the compiler settings. It'll be under output and where you want to put it. And just tell it to put it right into Unity. The nice thing about that is that then you can just build in the editor, moves it right into, or build in the, the IDE, puts it right into Unity, and then when you open Unity, it's right there ready to go. Let's see here. Okay. Will native plugins work with Unity 5? Yes. No, or for free, no. Unless they added that and no one told me. I don't, as of right now, no. Let's see here, and cool. Okay, so basically, yeah, right. So kind of as a summation, some people are asking how do we build OS X code. Mac code can only be built on a Mac because it uses Xcode, which is only available on a Mac. So if you want to do native DLLs for iOS or a Mac, you need to be on a Mac. Okay, so let's talk about writing some smarter code. Let's talk about writing a wrapper to the functionality of these DLLs and then using that in our actual Unity project. So I'm going to create a new C# script, and I am simply going to call this random number wrapper. Random number wrapper, which is going to kind of encapsulate the functionality for us here. And let's go ahead and open that up. And inside here, first things first, this is not going to be a mono behavior. This is just going to be a wrapper for the DLLs. So none of that stuff and none of that stuff, right? Easy peasy, nice and empty. All right. So this this wrapper is basically going to be our interface, if you will, between Unity and our multitude of native DLLs, or native plugins, right? This wrapper is basically going to navigate that system so that we can, in Unity, continue just writing code without really worrying about it, switching between platforms, never being concerned about it, right? This is kind of the intermediary, or the man in the middle, if you will. And so what we're effectively going to do is we are going to have a whole bunch of preprocessor directives, right? If defines, if you will, to determine exactly which platform we're on. So I'm going to say something like this. I'm going to say, hey, if, right? And what I want to know is which platform am I on. So I'm going to say if Unity underscore standalone underscore Windows, right? So if I'm in Windows right now, then I'm going to define a constant string called DLL, and I'll set it equal to, and this is the name of the DLL. In this case, it's going to be random number, number DLL. Okay, easy enough. But what happens if I'm not on Windows? Let's say I'm on OS X. So I will say elif, which basically means else if, Unity underscore standalone underscore OS X. Okay, so if I'm not in Windows, then I am in OS X. So in that case, I'm going to say, and I'm just going to grab this whole string. In this case, instead of calling random number DLL, I'm going to say random number bundle, because that's the name of the file. Remember, the name of the file is random number bundle dot bundle. I don't need that second dot bundle. Unity knows. Just random number bundle is the name of the file. You'll notice it turns gray. It turns gray because Unity knows I'm not on an OS X platform, right? But if I were to just take this project and move it over to an OS X, this would be gray, and this would have all the nice fancy colors, right? So Unity just knows which one I'm in. All right, so now I'm going to say elif, all right? And this time I'm going to say, hey, do I happen to be on iOS? So Unity underscore iOS. If I'm in iOS, I'm going to do the same thing, only there's something special about iOS. iOS doesn't load individual DLLs or libraries or plugins. It turns them all into one gigantic plugin, one gigantic library, which it calls underscore underscore internal. So that's how we reference it. And then finally we can say endif. So cool. So basically, as I switch platforms, and I wish I wasn't just, you know, obviously I'm on Windows right now. If I had OS X here, I could just load it up and you would see that turn and this change. And or if I was able to show this to you on iOS, you'd see that light up and this. But the nice thing about these preprocessor directives, because you can do like application.platform, right, to determine what platform you're currently on at runtime. The nice things about these is they are taken care of at compile time, which means the rest of the code, this grayed out code, never makes it in to the product, right? Which means there's no performance hit, right? Does that make sense? If I use something like application.platform, that's evaluated at runtime, and actually it then has to evaluate that, right? I could do something like if application.platform, which is not going to let me do because I'm not in a function, and this isn't a mono behavior and all that fun stuff. But basically, it's better to do this where you can. You might see other stuff that does the if application.platform equals platform or runtime platform.iOS, right? Or platform, whatever, right? This is generally better. We try to do this because it's much more efficient. All right. I could do Android by doing just Unity underscore Android, which sure I'll do that. The only reason I didn't is because I don't have an Android library. I only imported Windows, OS X, and iOS because I didn't bother to build for Android today. But I could, and I did Android, and it would be some lib name, whatever, because I don't actually have a file for that. It's irrelevant. and actually, you know what, I will remove this because I don't have that file, and if someone now tries to build for Android, it would break. But cool. So basically now I have this string. That's all I've done so far. So I have a string which is going to have one of these values depending on which platform it currently is in. So now I'm going to do my DLL import. DLL import, and you'll remember that DLL import takes in a string. This time I'm just going to pass the string DLL. It's going to dynamically load whichever one that just happened to be. We're also going to know that DLL import doesn't work without interop services, so we'll add that right there. So this will now import that DLL, and I'm going to say private static extern int, ooh, that's not right, int get random, just like this. So that's the signature. I can do this because this signature here exists in this library, and this library just happens to be built for those specific platforms. All right? So again, that's all fine. This is great. And now here's the kicker, right? We need to modify a function that will be called, right, by the rest of Unity, and we need to modify it so it will work for all of our code, right? The reason is if I'm on Windows, I want this to work. Right? I switch to OS X, I want this to work. Right? And it will right now. But if I switch to Android or Linux, right, this won't work because it doesn't have one of these, right? And so the whole thing is going to kind of go nuts, and it's not really sure what to do, right? And so we need to be smarter about our code. And really, I really should do. I should have an else, and that was my fault. So constant string DLL equals nothing. All right. This will make it so it won't crash on a platform we don't have anything in, right? So just nothing. All right. And then so let's modify this. Or let's create a function that's going to be intelligent, right? So let's do public int. All right. And actually, let's make it static. Public static int get random. We're just going to name it like this, so there's some obvious disambiguation between the two, so we know which one is which. Right? We're giving them a name. And so now inside here, again, we could do, like, you might find tutorials that tell you to do, like, if application.platform equals runtime platform.iOS, whatever. It's still better to use these macros, these pound defines, preprocessor directives, right? And so what I'm going to do is I'm going to say if, I don't know why it does that. So, no. There we go. So I'm going to say if Unity standalone Windows, right, or Unity OS X, or Unity iOS, because these are the ones I have a function for. So if it's any of those, I'm going to return, right, get random. Now, I'm going to say else, and I'll fix the tabbing on this in a second. So else is basically, it's not one of these three platforms. I'm going to return -1. We can see it turns gray because it's never going to call that code. And then we'll say end if. And let me just fix some of this tabbing here. There we go. And so basically now, if we're on Windows, we'll load our Windows DLL, and we will obviously load here, and then we call the function. If we're on OS X, we'll call the OS X DLL, and we'll call the function. iOS, iOS. If we're not, we're going to load an empty DLL, right? And we're just going to return a -1 as a dummy value because it didn't work. Doing it this way means that we can constantly be switching our platforms without worrying about anything else, without worrying about code failing. And if we happen to get like a -1 in our function call, we'll know that either it didn't load the DLL, or we're on the wrong platform, or whatever. So now that this is in place, right, let's just go back to Unity for a second here and make sure I don't have any compilation errors. I don't. Let's go back to our test native script, which is our mono behavior, and we're going to modify it. So we're going to get rid of this stuff, because that stuff is done for us now. Don't worry, I'll leave time for QA at the end here, because I imagine a lot of you have questions. And so inside our start method, now all we're going to do is say print native random number, but instead of this get random, we are going to say random number wrapper dot get random num. So we're utilizing the static function of our wrapper, right? And so now as we switch platforms, it's not going to be a problem, okay? So that's all saved. Let's hop back over here. Let's go ahead and hit play. and we'll see we get our random number. Now, and I'm not sure it'll let me do this. Let's find out. Let's go to build settings. I'm going to pick Windows to OS X. Actually, just close that. And did that? Will that automatically switch? It does. So you can see, yeah, perfect. So I said that I'm building this for OS X now. So we can see the Windows one turned gray, OS X one lit up. So now we would be using the OS X DL or the OS X library, the .bundle file, right? Let's take it a step further. Is it going to let me do build settings, iOS? Maybe. Hey, I've never actually bothered to try. Oh, there we go. Yeah, fantastic. Interesting though. I might need to look at this for a second. Or maybe I wrote something wrong here. But basically, iOS, it's saying that we're both iOS and we're not. So that might be a bug. I'm using a beta version right now, so we might have a bug there. But there we go. Okay, so, and we can see it switches for that. And if I were to say change one more time, build settings, Android, switch platform, we're going to get, oh, DLL name can't be empty. So that's my fault. But anyway, we could fix that. But we can see now return 0 or -1 would be would be called here and not actually that. And we'd see it all continue to work, but obviously we can't leave that empty. So we'd put something in there or just we'd do something to avoid this particular mishap. Maybe just skip this bit altogether and just returning a -1 or whatever. But anyway, so you can see what I'm getting at here. Basically, we can allow for this sort of smart switching between the two, and then our DLLs will work well, and they'll play well together. And this is all with just native plugins. Now, again, I'm going to reiterate now that we're kind of at the end. These plugins haven't been syntactically fantastic, right? We haven't accessed any hardware or whatever. I'm more interested in showing you how Unity uses the plugins instead of the actual contents of the plugins, which is by and large irrelevant, right? It's just C++ code in this case. More interesting thing is how to set it all up, all right? So, let me go ahead and I'm going to read back through the chat here because I'd like to make sure I'm answering any questions that people have. And I'm going to have more of a question time here in just a moment, but I do want to read through these here. Let's see here. Let's see. In my test, porting C# to native DLLs gave massive performance increases. Native runs fast. C++ runs fast. Yeah, absolutely. C++ is a great language for moving quickly. Let's see here. Native marshalling is costly. I've not bookmarked or benchmarked marshalling from one to another, from native and back and stuff like that. So I couldn't speak to how slow it is or inefficient. Possibly. I've not tried it. All right. What about Android? Okay, so we're to that part. Let's see here. All right. Why did I make it static? I made it static. So they're asking why did I make the function static? I made it static so we could call it without needing to instantiate an object to the class. We could have instantiated an object to the class, but it was easier to make it static. Let's see here. And that's kind of what everyone said in chat. What is making it static more efficient? I mean, we don't have to instantiate an object to the class, so in that regard, it is more efficient, but in a very small way. Plus, you have to be careful with statics. Not static functions so much as, because they don't get cleaned up unless all the references are gone. Let's see here. Will there be a Wolfram language plugin for Unity? Not that I am aware of. We've seen some of the Wolfram language stuff. It's pretty neat, but to my knowledge, there's not a plugin, but who knows? Maybe they're making one and I just didn't see it. Can you discuss Java a bit? What do you mean? So basically, Java, the language Java, can you make DLLs with Java? I don't think you can. Well, I don't know. It's been a long time since I've done any Java programming, so I'm not sure you can make libraries with Java for use in a C-based environment. Maybe. So I guess no. I can't really talk about Java all that much because I really don't. It's not anything I've ever done. What's the main benefit of using a native plugin? It's fast. You get access to hardware. It's fast. You get access to hardware. I mean that's it. That's why we would use it, right? To access things like the Oculus Rift or projectors with multiple screens or special GPS units or cameras, and that's all hardware-based native stuff. Someone asked, am I supposed to do Unity iPhone versus Unity iOS? I am under the impression that iPhone was the old one, and since they started having iPads and things like that, we switched to iOS. They both exist. I'm pretty sure the new one is iOS and the old one is iPhone. However, I might be incorrect. I just generally use iOS. But I might be wrong. Okay. Would you consider plugins an intermediate or advanced concept? Yeah, I suppose intermediate, maybe. As long, the code is the code. And a lot of times, and this is true, a lot of times you won't write the plugins and you won't write the libraries and DLL stuff like that. Someone would give them to you. You might buy a software package and they'd be like, here's a DLL. And you might be like, well, what do I do with this? Right? I have a DLL now. What am I going to do with that? And they're going to say, import it into Unity and access its API to tell it to do things, right? Here's the documentation, right? And so, yeah, so sometimes, a lot of times you're not going to write your own DLLs. They're going to be given to you, or you're going to buy them, or whatever. Sometimes you'll write your own, right? Depends on what you want to do. Depends on if you're a team, a lot of people, and very specialized, or if you're by yourself and you're kind of doing everything yourself, or you're trying to interface with a lot of technical hardware, or whatever. There's a lot of different ways these come about. Let's see here. Yeah, so Lightstriker_QC says it well. Basically, we use these plugins for anything that Unity doesn't include, right? Obviously, Unity itself doesn't have a lot of hardware-specific code because it wouldn't work on most of the platforms. It's very specific. We can also write plugins to interact with rendering. Right, so we can use plugins to change how things are rendered and to talk to renderers and stuff like that. They're on their own thread and stuff like that, but you can basically use plugins for that. Let's see here. Haptic devices require DLLs? Absolutely. How can we use callback from native Objective-C code? So that's actually a really interesting one, and I wish I had more time to get into that. But specifically for iOS, originally I developed this training as an iOS training, but since I don't have my streaming software on my Mac, I have it on my desktop PC. Obviously, it's a little bit more difficult. But basically with iOS stuff, specifically Objective-C, we write our Objective-C code, and then we use a C bridge to kind of bridge Objective-C to C, and then that C bridge is what's called from within Unity. So it's basically like one function calls another function, which in turn calls another function, right? And that's how we translate from one to the next. And that's where marshalling comes in. Okay, let's see here. Someone said, marshalling can be kind of a headache, transitioning from one memory type to another. Objects from C++ to C# stuff gets kind of difficult. All right. So, okay, so these are kind of devolving into sort of the same questions over and over. So I'm going to go ahead and wrap up now, and I'll stay in chat. We can continue talking in chat. But before I go, again, I just want to sort of plug Twitter. Questions, comments, concerns. Follow us, talk to us on Twitter, at Unity3D, at Mike Geig, at Will Goldstone, at The Ant Ranch. And we will do our best to help you, answer any questions, lead you in the right path, talk about sports. I won't probably talk about sports. I don't watch a lot of sports. But, yeah. So anyway, questions, comments, concerns, let us know. Thanks for watching. I know it's kind of a dry topic. It's interesting if you really know these languages and you want to know about plugins, but if you don't really know what plugins are and you don't really know C++, then all of a sudden you're like, what is happening, right? So I appreciate sticking around and watching. I know it can be kind of a weird topic, but hopefully this was a successful introduction, right, to just how Unity interfaces with basic plugins, right? And you can kind of go from here into either writing your own or utilizing your own now that you know exactly how to bring them into Unity The rest of it's just kind of salt to taste. It depends on what you're trying to make, just like anything else. So thank you all for watching. I hope you enjoyed, and like I said, Unite is next week, so we don't have anything currently scheduled as far as live training goes, but when Unite is over, you're going to see us add some new stuff. Unite just tends to be a lot of craziness. So until then, thank you all for watching, and I will talk to you later.